This is the seventh and final video of the Chapter 12 lecture notes. So thank you for sticking with me through all of this. It might seem like a long lecture, but remember that this is 2 days of class split across this whole chapter. So that would be something like 2.5 hours of content that we're covering here in this chapter. So I left off the last video talking about how the Tukey test, we're going to make pairwise comparisons. And so we're going to compare all of the different pairs of means. So we talked about these 3 different pairwise comparisons that we're going to make. So all we need to do next is just look back to probably in step 3 where you have all of the data listed that are associated with each of these groups. So looking back to our data, we see that the mean for the pizza group, if you were to calculate out the average of all those scores, right, don't forget what a mean is, still means the same thing, and that is the average of this group. So the average for the pizza group, you should have 1.75. When you take the average for this beer group, all of those scores, that should give you 3.75. And then if you were to take the average of this control group, so the average of each of those 4 scores, you should get a mean of 1. So we're going to use each of those means in our pairwise comparisons. So we're going to take the mean for the pizza group, which was 1.75, and we're going to subtract the mean of the beer group from it. You'll notice that I placed some absolute values around these mean comparisons. That's because we basically just care to see what the difference is between these 2 means. It doesn't matter if it's positive or negative, because again, you can put this in either order with beer first or pizza first. So because of that, we'll take the absolute values for all of these pairwise comparisons. So when you subtract 1.75 minus 3.75 and take the absolute value, it gives you 2. We'll do the same thing for the remaining pairwise comparisons. So the next pair of means we can compare is the pizza to the control group. So we'll subtract the pizza mean, which was 1.75, from the control mean, which was 1, and that gives us a difference of 0.75. And then we'll do the same thing for our last pairwise comparison, which was beer versus control. We'll take that 3.75 minus the mean of the control, which was 1, and that gives us a difference of 2.75. So the next step here would be to compare each of these differences. So each of those mean differences, we want to compare each of these to the HSD value that we calculated up here. Essentially, if our mean difference that we calculate, so the difference between our 2 means, is bigger than our HSD value, then we would say that that difference is significant. So in looking at this first pairwise comparison, the value of 2 is indeed bigger than our HSD value, so we're going to put a little star next to it. The star indicates that the difference between these 2 groups is significant. So again, we're just looking at this number. If it's bigger than our HSD, it's a significant difference. Looking at our next group, we have a value of 0.75, which is not bigger. It is smaller than our HSD value. Since it's smaller than that HSD value, I'm going to put an NS next to it to indicate that that difference is not significant. And then finally, we have our last pairwise comparison, so we're going to compare that 2.75. Indeed, it is bigger than our HSD value. So again, anytime it's bigger, we're going to put a star next to it. That indicates that that difference between those 2 means is significant. So earlier I had to be continued on our conclusion, so we're going to go ahead and revisit that conclusion. So essentially what we want to do is we want to add to our conclusion our interpretation of these Tukey test pairwise comparisons. So I think the easiest way to do that would be to make a sentence explaining each of these pairwise comparisons. So for example, we'll make a sentence comparing the beer group to the pizza group and indicate that yes, that was significant. We'll have a sentence about the pizza versus control group, indicate that that difference was not significant. And then finally, we'll have a sentence comparing the beer to the control group and indicate that that was indeed significantly different. So the way that you might include that in your conclusion, so I just shortened that first part, but the next part here should be added right after your eta squared. So after your eta squared, we're going to add this remaining part of our conclusion. So we'll say something like a Tukey post-hoc test revealed that the pizza diet, and then we want to say what the mean was. So the mean for the pizza group was 1.75. So the pizza diet was significantly different from the beer diet. And we'll have the mean for that beer diet. So again, I'm getting these interpretations from that last slide of the Tukey test, where we found that the pizza group significantly differed from the beer group. So that's how I'm going to write that in my results. I'll make another sentence. This one actually is representing that third pairwise comparison we did. The only reason I switched the order is because it's usually better to talk about your significant differences first and then your non-significant ones. But that's really just a style thing. It's not a requirement. So I'm going to say next that the beer group, the beer diet, also significantly differed from the control. So again, I'm getting that from the last slide where we put a star next to that pairwise comparison comparing the beer versus control. And then finally, we're going to say that the pizza and control groups were not significantly different. So you'll notice that I didn't say anything about weight gain here, and that's fine mainly because the first sentence in our conclusion indicated that we were comparing each of these groups on weight gain. So given the context of that, it should be obvious. So that is the end of our conclusion for the ANOVA. You'll notice that it is a pretty long paragraph once you finish writing it all. One other thing I wanted to point out is that we have each of our means for our groups. We just need to list each of those once. So since we listed the mean for the beer diet right here, we don't have to repeat it again. Since we hadn't yet mentioned the mean for the control group, we do want to make sure to mention that the first time we're discussing that group. But we just need to make sure each of these means is reported once. And then once it's reported, we don't need to repeat it again. So another commonly used post-hoc test is called the Sheffe test. I'm not going to go through how to calculate that by hand, but we are going to use this in our actual SPSS interpretations. And the main reason is because the Sheffe test, it can be used when we have unequal sample sizes across our groups. So remember that a requirement of using the Tukey test is that all of our sample, our number of people in each of our groups, it needs to be equal across our groups, not a requirement for the Sheffe test. And so that test will use an F ratio test to test each of those pairwise comparisons. We're going to go through that in more detail though when we go through the results in SPSS. So just know for now, the main difference between the Sheffe test and the Tukey post-hoc test is that one of them requires your number of people in your groups to be equal, so that would be the Tukey test, and the other one does not. Last but not least, let's talk about the assumptions associated with the independent measures ANOVA. So just like every other chapter for the most part, one of our assumptions is that the observations in our sample need to be independent, so different people measured in each of your groups. A second assumption is that the populations that we're taking these samples from need to be normally distributed. So the scores in those populations, so we were measuring weight gain, so the measure of weight gain should be normally distributed across the population. And then finally, we have that same assumption that we had back in chapter 10 regarding the homogeneity of the variances. Basically, what that assumption is referring to is that we should have about the same amount of variability across all of our groups. So we have our pizza group. Those people should be just about as variable as the people in the beer group are from each other. And also those people should be about the same amount of variability between their scores as there is in the control group. So all of those groups need to have about the same amount of variability in each of those groups individually. So there needs to not be a significant differences. There needs to not be significant differences in the variability across those groups. So that is the final assumption, and that marks the end of chapter 12 notes. Hooray! I hope you had as much fun listening to this as I had making it, which I'm sure we would all much rather be doing this in person, but we got to do what we got to do. So I hope y'all are taking care of yourselves and enjoying at least not having to, put on pants or whatever it is you do at home. Hopefully you're relaxing a little bit and helping yourself cope with the stress of this situation that we're all in. So if y'all have questions about any of this, please do email me. I am available to meet over the phone or over email. Usually I'll probably ask you to either have a phone meeting with me or Skype or Zoom. So I'm available to meet in a number of different ways. So please do get in contact with me if you have any questions. So take care of yourselves, and I will return with other videos. Bye.